All right, I think everyone can see my screen now. All right, so thank you so much all for joining us today. As I was saying before, my name is Muhanned. I'm a senior trainer here at Recoded, and today I'm going to be talking to you about how you can start your career as a backend developer. So the agenda for this session is going to be me introducing to you to the backend developer and just talking a bit about what exactly is backend development. We're going to go through the technical skills that you need to become a backend developer. And then we're going to talk about things that you will need to thrive at your role. And then some soft skills that are required to be a successful, whether you are a backend developer or just a developer in general. So without further ado, let's talk about what exactly is backend developers or what exactly do they do. So a backend developer is someone who's working on maintaining the server, the APIs, the databases, the whatever is happening in the server side of a website. So for example, if we say that you logged into a website like Facebook, then the backend of that part of the website is going to be fetching all your friend lists. So, representing all those friends for you, and then all the posts that are being latest in your feedback. And then whenever you, for example, click share or like, add a comment to a post or whatever you're doing, then the back end of that is adding those to the database and then fetching them and displaying them to everyone else who's using the platform. Of course, it's like everything that is happening at the back end. You're not really interacting or seeing what's going on. You can definitely like inspect those and check the fetch and requests on the network tab in your inspector in your browser. You can just like skim through them, just see what kind of requests are being sent to the servers and what response of the servers are returning to you. So what is actually the skills that you might need so that you can become a backend developer? So there's like four main categories. Under those, there's like a lot of techniques that you need to understand or become fully familiar with in order for you to kind of start your career as a backend developer. So first of all, we're going to be talking about the servers, which will be responsible for you to hold your work on them. So whatever code you're developing, whatever platform you're working on, they're all going to be coming under servers. So for example, your continuous integrations, continuous development, which is referred to as the I and CD, the caching mechanism for some websites. So if you have a server that is loading heavy data to the clients, then you definitely want to add some caching services like Radius or anything else. And then the security features that you need to have to surround your APIs or calls on your network so that you don't really allow malicious users to get into your backend and mess up with it. You're also going to need to have some knowledge about databases, which you will need to store data in. So there's like a lot of other stuff that you can do with databases. You have MySQL, you have PostgreSQL, DB, you have DynamicDB for like services as AWS and other providers. So there's like a lot of databases that you can go through. Programming languages are a very interesting part. So you have a lot of programming languages that you can work with. For example, JavaScript, you can work with Python, you can work with Go, you can also work with Ruby on Rails. There's like a lot of languages that you can actually try to leverage so that you can become a back developer. And then there are like development principles or development techniques that you need to understand. So how to design your APIs, what is data structure, what are algorithms, how can you prepare your backend so that it becomes really fast when you're actually trying to cache for data, trying to retrieve data from the backend or from the server that you have. So those are like skills that you might need to become a backend developer. So for servers, for example, we have Nginx, Apache, SIS, a lot of like different servers that you can go through, Linux, Windows Server, this kind of stuff. They're all different platforms that you can work with. And you just need to know like one of them or how to actually work with them in a very simple manner, unless you want to go deep into it and try to figure out the caching and security and other kind of aspect about it. For CI and CD, as I said before, the continuous integration and continuous deployment, you need to kind of prepare your pipelines so that whenever you are trying to deploy something, it automatically get tested. It automatically get deployed into your testing environment, and then you immediately can see the reflection in your testing environment. And then once that actually is approved, you can move on and go to the development and then the staging state for your server, and you can see it live in your website. So whatever like pipelines or whatever dynamics you have prepared for yourself, you need to have it being cached and being as automated as much as possible so that you can have an easier workflow to work within. CDN, which is content developer networks, are websites that you can actually use so that you don't really have to download everything to the client side. So for example, when you're trying to cache, if anyone has worked with Bootstrap, for example, you can either add them locally to your work project, or you can refer to their by the CDN so that they really just grab whatever is needed and they don't really have to download the whole thing on the first time they are running their website. What is client side, what is server side, how to can actually, cache between them, either using like Redis or memcached, which is like different techniques for the same thing. And then you have other things about virtualization, for example, using Docker or Kubernetes, or just using the or regular virtual machines so that you can mimic multiple servers or multiple services if you are working on the same website. So they are, so each service is kind of work in its own environment, and then you interact with them in whatever test logic that you actually have. So there's a really good website that I'm going to be sharing with you right now. This website is actually called the Map. So what this website is doing is that you have like a lot of things that you can go through. So you have a roadmap to become a front end, a roadmap to become a backend developer, DevOps, React, Angular, Android, this kind of stuff. So if we go into the backend and we just look through it, now don't panic if it looks like a lot. This is like a lot of stuff to go through, but you don't really have to understand everything at the same time. You just need to start off with something and then you move forward with it. So you can see here that they have what is called like a personal recommendation or a personal opinion. I'm going to be sharing the link in a bit. It's called roadmap.sh. You have like alternative options, so you can pick like multiple stuff to work with. So for example, if we go to languages, so you can see that they're recommending JavaScript, but then you have Python, you have Ruby, you have Go, Rust, Java, C#, PHP. So there's like a lot of languages that you can go through, but you just need to like learn one of them or like whatever is related to what you are working with. So order and roadmap is not strict, so you can learn them anytime, which is like a gray check mark. And then you have I wouldn't recommend, which is this great area. So you can see that you need to start off by just understanding how the internet is working, what is an HTTP request, browsers and how they are like rendering and displaying information, what is a DNS, domain name provider, how to host your website. And this is when we're talking about like servers and their different way of hosting things. And then like the basic knowledge of HTML, CSS, and JavaScript. Then you kind of need to understand more about general knowledge about operation systems, how they are working in general. Either you're working with a Linux distribution, for example, or you're working with a Windows. It's completely depending on where actually you are hosting your website and what services you are actually doing. Threads and concurrency. So when you actually receive multiple requests from different client sides, how does that actually apply? How do you actually handle them? What is the advantage of the operation system and the languages that you are using right now versus like the disadvantages that you're going through? The input and output management, those kind of stuff. So those like contain a lot of like information. So some of them you would actually find an explanation, and then I believe some of them you can actually have links for videos and stuff to read about. So you can definitely just like go through them, watch videos, read articles, this kind of things to just gain the knowledge that you actually need. And then it's just like, you can just like simply just copy it and just Google about it and just like try to learn more about these techniques and what actually do you need to go through them. So you can see that this roadmap is just like driving you through what you need to understand and learn so that you can actually become like a better developer and just go into the back-end development world. So I'm going to keep this here open and then I'm going to go back to the presentation just quickly. So as I was saying, the next thing you need to understand is related to the databases, how you can actually store the user's data. So for example, if we go back to our Facebook example, one of the basic things that you actually need to store about the users is, for example, the username and the user email and the user password. This is like the basic things you need to store in your backend. And then you just need to do an API request so that you can make sure that whatever password he used to log in is actually the same password that he used when he registered. And here comes another security issue. So do you want to actually save this password in plain text, or do you want to actually hash it? And in your database, you have no idea what the password is, but you have a hashed version of that password. So every time me as a client, I log in into Facebook, I give them my password in plain text, but then they take it and then they hash this password, and then they go and compare it between, against the hash that they have in their database. Another security thing you need to worry about is with the connection from your machine to the Facebook servers. So at the beginning, is it going to be a plain text sent directly to them, and then in the backend they will hash it, or will the hashing happen immediately in your browser and then be sent across the network so that if someone interrupts this data, they don't really know what is the password and they only get the hash that you have. So there's like a lot of things that you actually need to worry about when you're working with this kind of things. But as I said, this is like a journey that you go through. You don't really have to understand everything at once. You don't really have to go through all of this in one point. You just need to take your time with it and just start small and easy and go through this. So those, the ORMS, ECID, those are all retrieving information from databases issues. So how many requests am I going to do to query some data from the back end? So am I going to keep reading every time the user like hits, let's say, for example, if I go into another person's profile, if we go to the Facebook, I'm going to be talking about Facebook a lot today. So if you go like to someone's profile, what exactly is it that I need to fetch? How many times am I going to be fetching this data? So for example, do I need only the latest posts that he have, and then the user is going to go into another page, or do I need to actually load all his posts and then the user is going to have to go through all of this? So this depends on how fast my API is going to be and how is the loads going to be distributed on my CPU and network resources in the backend. So those are all things and techniques that you need to think about when you're actually designing your backend and your websites. You need to know how many users do you have, and then how many data can there be in your website. For example, someone could be posting like 10 Facebook posts a day. Another person would be having like one a month, or less than that. So you need to actually be careful about those, and you need to think them through and design your API and your backend around those kind of short edges. So for programming languages, as we said, there is a tons of programming languages that you can go through when you are specifically working with the backend. You can go with Python, PHP, JavaScript, Ruby, Java. So a personal preference of mine is JavaScript. I would say that it's the easiest to just like break into the field of backend development. It's proven to be really a big competitive. It's actually a very high on demand. So you really definitely need to understand JavaScript. It's kind of easier because when you actually start going into web development, you learn about JavaScript because you're working, for example, on your front end pages. You're trying to do like the basic JavaScript in your website, or if you're working with technology, for example, like React, Next.js, Angular, this kind of things. So all of those can be easier for you to kind of break into the back end and then work with JavaScript. There's a lot of frameworks that you can actually work with. The most famous one is Express.js, which allows you to kind of build APIs, do a lot of security features, and then they handle everything for you, and you just need to work around it. So it's definitely easier. PHP is a huge contestant. It's been there for a long time, with C# as well. Python and Ruby are kind of new into this. They're not the same as PHP and C#, but like definitely whatever you feel you're passionate about and what is easier for you to kind of go into. At the end of the day, any programming languages can be completely perfect for this, because you just need to understand the basics. So if conditions, loops, variables, those kind of different stuff. And then what's going to be different is the syntax. There isn't really going to be a huge difference between them, only the syntax, and then the way they are handling the backend services and how they are doing fetching, requesting, this kind of stuff. So it's just a sugar syntax, nothing really that complicated. Development principles. So those are some stuff that you actually need to understand about how to build an API. So for example, if you're working and if you're trying to kind of develop an API that can actually respond and interact with the end user. So for example, if I log in, you need to have an API for logging on. There's going to be a different route for registration, for example. Another for retrieving the data of the user, another for retrieving the friend requests, another one for retrieving messages history. So there's going to be like a different API for each one, and you kind of need to understand how those APIs are designed, what are the parameters that I need to pass into those APIs, and then what am I expecting those APIs to return to me, and how can I actually decipher those requests. You also need to have like a really good documentation for your APIs, so that whether you are working on them or someone else is working on them, you all can actually understand each other, and it's simpler to kind of go through them and develop with them. Like a great documentation can go like a huge way in making your work look really professional and really easy to understand and use with. Authentication techniques. What do you want to use? Is it going to be a JSON token? Are you going to use OAuth? Like there's different techniques that you can use. They all have their privileges and disadvantages. You just need to weight them against what you're trying to do, what you're trying to accomplish, and then decide on whatever you're trying to do. Search engines is what do you actually need to do when you're retrieving the data. So for example, if you have like a lot of data in your website and you want to implement a search functionality, or if you're just simply doing a query from your database, if you have those kind of things, you kind of need to know how you're actually going to search through them. What is the best algorithm to use in this one? How can you actually make your backend move faster and retrieve data in a more efficient way, so that you don't really end up wasting the client time and your resources on something that is not necessary. Also like algorithms and data structures, so that you actually know how to hold and retrieve data in a good manner that is more efficient and more easy for people to actually use. So how can you actually thrive at your role, and how can you actually move to the next step? So there's like a lot of things that you can do. The basics is understanding version control. You have testing as well, containerization, and then the design architecture and patterns that are used and followed in backend development. So if you start with version control, you can start with Git or any other version control system, but Git is the most famous right now. So understanding and knowing how to actually start a repository in your own project, and then how you can actually make good commits, branches, how's the workflow is going to be between you and your team, and then understanding a remote version control system like Bitbucket, GitHub, or GitLab can go a huge line in making you distinguished from other developers. Understanding Git is going to make it a lot easier for you to actually develop and maintain your website. You need to actually also follow whatever principle you are following in your company. So how often do you commit? How often do you push your commits? How often do you merge those commits? What kind of commit messages you're following? What kind of commit approaches you are actually following as well? How can you actually do an efficient and active Git review? CIs and CD actually goes a lot into this. So, for example, whenever I deliver a pull request against, for example, testing environment or master environment or whatever environment that I want to go into, what exactly is going to happen? Is the continuous integration going to go and test this code and make sure that it just skips all the basic testing, so it doesn't really flag any errors with our environment? We don't really have any unused variables, or we're not really breaking any rules that the whole team agreed upon. And then deploying this so that end users can actually start testing this feature and take a look at it if you have something like this. And then once we actually review and approve all of this, and we merge this into the let's say for the testing environment first. So there's like a lot of different ways that you can go through this. So you can either merge it into testing, or you can merge this into development immediately and you can see it live. So like whatever approach you are following, this all needs to be handled using version control plus CI and CD. So it's a really great resource to start with and learn and invest your time in, so that you can actually have a very professional Git history and Git repository management. The second thing is going to be testing. So there's a lot of type of testings. The most famous one is unit testing, integration testing, and end-to-end testing. So whenever you are trying to develop a new feature, you're always going to be in danger of actually breaking already working features. And the best way so that you don't really go through this and you don't really break your own code is by having tests running in the background. So whenever you are delivering for example, a new EBI route, then you have to know that there is a testing for each endpoint or each output that is being expected out of this route. So that furthermore, if we decide to change something or add something to this route, we make double sure that we don't really break something, because the test is going to be running automatically. And if it runs against anything that is not really supposed to be breaking, then it's going to give us an error immediately, and we can check it out. So this is something that, sorry for this. So this is something that you really need to make sure about. So unit testing is like very simple testing. You just test one simple thing. You don't really care about the overall picture or the overall project that you have. So for example, let's say that we have fetching posts or getting all the posts in a database. So I have a route. This route is going to return to me all the posts that I actually have when I visit this one. A simple unit test that I can actually do this for this one is that I can check that if you just go through the / posts, for example, the most general one, you can get all the posts that I have in the database. But if you, for example, pass in a variable like an ID, this means that I just need a specific post, or I just need a specific post for a specific user. So I don't really need all the posts in the database. I just need it for that specific user that I have. Then this is called like a unit testing. I'm just testing one thing. I don't really care about other stuff. If we move on to the top, which is integration testing, then I have to make a test so that it can test everything that is happening in the post route. So the general post route, and then if I pass in an ID, and then if I pass in, for example, a date, so that I just want to get all the posts that are happening, for example, in the 10th of May, or in 2020, or like specific date that I want to go. So I have to test all of this route, and I have to make sure that all of it is working. So the whole /post endpoint is actually working for me. This is going to be called like an integration testing. If you go up top a little bit and go to end-to-end testing, then this means that we have to kind of have a more general test that I just go through the whole platform, and I'm making sure that my API is all working. So this is like what testing is going to be beneficial for. you don't really have you don't just have like a feature that just like keep pushing and pushing and you have no idea what's happening in your own environment. You are making sure that every time you update something or every time that you add something to your code or backend, that immediately something is going to be tested, and you're going to make sure that this code is not really breaking anything that is happening before. Because sometimes we might be adding something. It can simply be as, for example, we have a library. That library got updated. When we actually started, integration, a new feature, we updated all the libraries, and then the update actually broke our features, our previous features. So our whole platform is not working anymore. And because we're not really focused about everything else, we're just focused about the current feature that we're working with, we might not really go into it, and we end up shipping something that is completely destroying the backend and destroying our project. So testing helps us to keep everything in check, and we are making sure that our previous work is actually working and that our latest work is actually working as well, so that whenever we're adding something new, we're not really running into something that is completely breaking our environments. Containerization is, as I said before, this is related to virtualization. So for example, if this can be as simple as us running a Linux virtual machine, a Ubuntu on a Windows. So we're just like operating a whole operation system inside our Windows, inside like VMware or the Oracle version of it. I can't remember the name of it. So you can use actually virtualization in web services as well, so that you can actually better enhance your backend and how your response or how your servers are being actually handling the responses that you're going through it. The most famous one right now is called Docker, because Docker made a lot of it revolutionized the whole idea of virtualization. So previously we used to have virtual machines, and those were really costly. Whenever you install someone and you start to run a 12 instances of virtual machine, then it's going to consume a lot of your CPU, a lot of your RAM, a lot of your network resources, and this kind of things. But with Docker, it became very efficient. It became very easy to kind of run multiple instances, and you can just like go through them without any issues. This is used, as you can see here from like this diagram. This can be as easy as me having a Docker container for my code. So I have like a complete isolated server that's just running the code. And then I'm dealing with services, which can be like a database. It can be libraries. It can be a radius in the middle that I'm doing caching inside of it. And when I'm talking about caching, what I mean is that, for example, if you look at Google, for example, so Google actually have their own server in each country. I believe in each country they have. So they just send them a server. This server helps this country is that every time I'm trying to Google something, instead of it going to Google servers in the United States or whatever country they are in, and retrieving the data from there, they would go into the local cache inside my country. If they have this input, so for example, someone Googled this result like 3 days ago or 5 days ago, then it's going to be easier to retrieve this data and represent it to the user than going to, whatever outside network, whatever country, the Google servers are actually in. So this can be like really super fast to kind of go through. So this is what I mean by caching. Caching is that I'm taking the latest results that people are really popular about, everyone's talking about, something that I'm sure that the users are going to be retrieving. And instead of me going from the end developer all the way to the database, I'm reaching the middle where I find my caching services. And then if I find the result, I immediately retrieve it. This makes it super easier and very efficient way to kind of handle your resources and responding to your end user. If I don't have it, then I'm going to go to the database. On my way back to the end user, I'm going to keep a copy of this inside my caching, so that next time if a user search for this, then I already have it inside my caching and I can serve it to it completely faster. So Docker comes into play here when you have this containerization, is that there is a design principle where it's called microservices. So the way that I'm actually managing, or the way that I'm I'm dealing with my backend environment as a whole is that I'm containerization each section of it, and I'm making it isolated from the rest. So I have a database. That database is going to be running in a different isolated container. It doesn't really interact with my other services. It doesn't really care about the libraries, about the radius. It doesn't really care about anything. The only thing it cares about is the database that it's running currently. And then I'm opening a ports so that I can actually retrieve information and deal with it. And then I have another container for my code, which is going to be running in its own different container. That container accepts requests, and then it launches this request and then provide them into the database. This way, whenever I'm adding a second database, whatever I'm adding another code base, whatever I'm adding a new service for caching or whatever I'm doing, it's completely efficient because I actually have everything isolated in its own container. I don't really need to go mess up with the code. I don't really need to go and add everything else. And going as a backup, for example, if this database, for example, at one time failed, then I can just simply point my code into another container and it will deal with that container immediately. And I don't really have to worry about it. So it makes the whole process a lot easier and a lot more efficient to deal with. And I don't really face many issues when doing this. So containerization is something really important in today's world, and we really need to know about it. And as I said, Docker is super efficient, super easy to learn. So definitely something you should invest in. So we have some design principles that we actually need to understand. For example, don't repeat yourself, keep it as simple as possible, and those other principles. So those are more to when you are developing or when you try actually to manage your entire code base. So you can make your code base very efficient. Your code base is not really repeating itself. You're maintaining a very clean code base, and you can just keep follow of everything that you're doing and maintaining those in a very efficient way. You have also design architecture. As I said before, there is something called microservices where you have everything containerized in its own container and it's completely isolated from other things. So you don't really have to deal with it. You have SOA, which is containering things that are related together in one container so that they can actually serve the same service as together, or you can have the whole thing being in one container and you can do a lot of this. So there's like a lot of architecture that you can actually go through. So you only need to just understand the basic, what do they mean about it, how can I set it up, and how to go through this. This is going to be super interesting to have in your resume and your work when you're actually sharing and displaying your work to others. So what is the soft skills that actually you need so that you can actually grow? So one of the initial soft skills that you need to do is communication, because communication is key whenever you're dealing with anyone else. So this is for whatever workspace you have, whether you're a backend developer, front-end developer, whatever you're doing, communication is going to be essential because you need to understand how to talk to people, how to actually understand what they're doing. Mostly you're going to be working with a front-end team. You might actually be working with a database team because your job is not really managing the database. Your job is just managing the API, for example, or the interactions. Like, it doesn't really matter. You have to communicate with people and deal with them. So you need to have a really strong communication skills. You need to know how to talk to people, how to explain yourself, how to listen to other people, and just get the information from them and doing this. Your teamwork skills should be top notch because you're definitely going to be working with other people. This is not a one-man job. As you go and as you scale and as you get bigger, you're going to be adding people into your team. You're going to be working with a lot of people. They need to understand what you're doing. They need to work with you together. So this is like something really essential for it. You have to be ambition. This is specifically particular for like people who are working on software developments in general. Every time we see, or every day we get a new technology, we get something new that people think of, something new that people add, a new framework, a new architecture. So we always need to thrive to become better developers and become ambitious about learning everything that is new, because they can take a huge step in making our work much more efficient and much more easier. And then it can make us actually grow as people. Humility, so that you don't really see yourself as more important than other people. You need to have people skills so that you can sit with them, be patient with them, understand what they're trying to do, becoming protective. Just people generally get really good around you, and they can really understand you and go through you, because people will find it really hard to work with someone who's not really listening, and who's not really understanding of what situation they are going through. So those are like the top like 4 skills that you might actually need. There's definitely like other skills that you actually need as well, but like those are like the 4 top options. I'm gonna start going through the Q&A and just like check what everyone else is